this doodle is about expressions and equations, and we'll get later to what those words mean. First, let's do an activity, and we can't quite finish the activity without a distracting bit of vocabulary. So we don't really care about square roots. We're not going to use them a lot, but let's get this out of the way so we can do something more interesting. And what square roots are, where it says root and square root, it really means the side of the square. So if I have a square that is 25, then each side would be 5. Similarly, square root of 4, if I had a square that had 4 pieces, square, then how long is each side going to be?
Is it 2?
It is. You could either see the 2 on the side, 1, 2, or you could just know that 2 times another 2 makes the 4. The square for 9 would be a little harder to draw, but I will do my best. So that square has 9 boxes. How big is each side for that square?
3.
3. So the square root of 4 was 2. The square root of 9 is 3. What's the square root of 16 going to be?
Is it 8?
There's 16.
Oh, 4.
4, yeah. It's not half. It's whatever you multiply by itself to get to that bigger thing. So 2 times itself is 4. 3 times itself is 9. 4 times 4 is 16. 5 times 5 is 25. Coincidentally, for the first of the pattern, it is half, but that's not how it stays. Okay, so now that we know what that is, we're just going to need it a little bit. Here's the thing we're actually interested in. There's a famous challenge to use 4 4s. And just like the invisible fairy race, you have to use all 4 of the numbers. You can't leave any out. And we want to make every number between 1 and 10. So as examples, without spoiling it, if we were wanting some of the teens, then here are ways to get 15, 16, and 17. But that's not part of our challenge. We're just trying to count from 1 to 10. So we're going to write stuff on the side of 1 is, and then tell me how to make 1 with 4 4s. It's sort of like we're playing the invisible fairy race, but our dice are cursed and only roll 4s. We can get 1 through 9 using just adding, subtracting, multiplying, and dividing. But to get 10 to really finish, we're going to have to use that the square root of 4 is 2. As notes in fine print, one version goes up to 20, but then you sort of have to cheat. I'm not going to worry about that. So can anyone figure out 1? How do we use 4 4s together to make 1? I'm going to pause the recording because otherwise it'll be a very boring recording as we brainstorm. Once we get some answers, I will resume the recording. So if you are watching this after the fact, try and do this yourself and then see how you did. So here's some of our examples with 1, 2, 3, and 4. Moving on. The reason we did that kind of review of the invisible fairy race type of thinking is to talk about equations and expressions. If we smash numbers together in a way that has an equal sign, then we call it an equation. So this top thing is one equation. Here's another equation, and here's a third equation. Equations have something to the left of the equal sign and something to the right of an equal sign. When we have an equation, we're saying that we know two things are equal to each other, and usually the next step is to solve the equation. We're either missing something at the end. If I do 4 times 3 and then add 4, how much is that? Or we're missing something in the middle. 3 plus something else is 7. What goes in there? And if we are in a lower grade, we might see boxes to write our number in. Once we get to a higher grade level, then we tend to put letters in, but they mean the same thing. It's just what goes in that spot to make this work. So that's an equation. There's a similar thing, and it's never emphasized enough early on. It should be something that teachers pay much more attention to. An expression doesn't have an equal sign. There's no equal signs anywhere in these. It's just smashing a bunch of numbers together. It could be exactly the same thinking. We're doing the invisible fairy race and we're trying to get to 15 with 4 4s, but I am not writing it with an equal sign. When we want to deal with expressions, the verb we use is we simplify. And that means we're going to just smash all these things together until we get one number. This one is 15. Something like that. This matters a whole lot later on because there are different tools we can use if we have an equal sign. You'll learn in algebra that we might subtract 3 from both sides of an equation, and then 3 plus something is 7 turns into something equals 4. But we can't subtract from both sides of an equation if there's no equation. If there's no equal side to say there's something to this side of the equal sign and something to the other side, then we can't use that tool. So we are not going to start dealing with equations yet, but while we are dealing with expressions, because we've been playing the invisible fairy race and trying to write down how to put these dice together, then we should know that that's the official name for what we have. If I'm putting a bunch of numbers together without an equal sign, that's called an expression. And if I put an equal sign in the answer, that's called an equation. Everyone okay with that vocabulary? Hesitant nods. Okay. Here's an example problem where we're going to put some numbers together. And maybe you would write an equation, or maybe you would only write an expression. How would we do this one? Yesterday, I picked 3.5 buckets of apples from the trees in my backyard. A quarter of the apples had bad spots. They were only usable for cider. They weren't the nice kinds of apples I want for pie. My buckets hold 40 apples each, and I can sell the apples that are nice enough for pie for 25 cents each. So how much can I make selling the nice apples? Again, I'm going to pause the recording and we can work on this, and then I will resume it. If you're watching after the fact, try and work on this before continuing. Here we are back. We had 3.5 buckets, and I just happened to draw this half bucket like it was cut with a sword up and down rather than half full like you would, because I ran out of space. So 30 and 30 and 30 and half of 30, which is 15, adds up to 105. Then each of those is 25 cents. we used the calculator, 0.25 times 105, and we got $26.25. On this challenge, we were going to use a 4 and 2 other numbers, and then try and make another expression that has the same value as the one that you did the first time. So the example that someone did, 4, and then they just picked +7 + 9, right? There's no right or wrong. You're just making up an expression. But then they had to say, well, what is that? 4 and 7 is 11, + 9 is 20. What's another way to make 20? Let's do 10 + 10. So if you want, challenge someone, friend or family, over the weekend and say, I'm going to make an expression that has no multiplication. Can you make one with multiplication that has the same overall value? Or something like that. You could make this more interesting.